Okay, so the way that I would approach this one is a little bit different than if I was just trying to graph it. But since they gave me graphs that I just have to match, I'm basically going to kind of do process of elimination and kind of confirm the major features of the graph. So we're given this equation, and so the first thing I'm going to do is find the vertical asymptotes, just because they're sitting right there looking at me. So for my vertical asymptotes, that's going to be our denominator set to 0. So we would have x equals -1 and x equals 2. And that's the zeros in the denominator. For our X-Intercepts, and that would be the next thing I'd probably do, again, just because it's easy and they're sitting here looking at me, X-Intercepts are going to be zeros in the numerator. And so I would have, when x is -2, that would make this one 0. And when x is 1, that would make these multiply to 0 and come out as a 0. So that will be my X-Intercepts. And then the other thing that might be handy here is maybe grabbing a Y-Intercept. So let's grab that real quick. For a Y-Intercept, that means that the x's are 0 and we're solving for this side. So let me write that instead of f of x is y. And that's going to be a negative right there. And then all these x's are 0, so it's just going to be 2 times -1 up top because those are dropping out. Same thing down here, 1 times -2. And then I got 1, 2, 3 negative signs. So it's going to be a negative, and then 2 over 2 makes -1. So my y-intercept is at 0, -1. And I bet that will be enough information to figure out which graph it is. While I'm here, let me find the the horizontal asymptote, just because this one's a little bit tricky. And you probably, I don't think you're going to end up, it would eliminate something, but it's not the worst thing to review. So if I was going to find the horizontal asymptote, that's the thing where we have to compare the degree of the numerator with the degree of the denominator. So if you think about foiling all this stuff out up top, we would end up with an x squared with a minus in front. So my first term is going to be -x squared, and then I could do the rest, but it doesn't matter for the horizontal. All we care about is that first term. And then likewise, if I were going to FOIL out the denominator, I would get an x squared with some more stuff that doesn't matter because we're only looking at the leading coefficients. And so right there, then our horizontal asymptote is the ratio of these two terms. So that's going to be y equals -1. It's easier to see this if I had 5x squared over 3x squared. The horizontal asymptote would be y equals 5/3. So it's this thing where it's a -1 and a 1, and they're, sort of the numbers that we don't write out. A lot of times people will have trouble spotting that. So I don't think we really need it for this problem, but there it is. So let's see what we could figure out now. We knew this information, we know that information, and we know this information. So starting with just the vertical asymptotes, -1, +2. So that first graph is correct. That second graph is not, so that one is eliminated. The third graph does have -1, 2. Fourth graph does not, so that one is eliminated. So we're down to 1 and 3 just based on these vertical asymptotes. So then for X-intercepts, this one has, we're supposed to have -2 and 1. So -2 and 1, that works on the first graph, and -2 and 1 works on the second graph as well, so that was not enough information. Horizontal asymptote, so that is the line where this stuff is going to approach. If you look at this graph, that looks right. That looks like that is going to approach -1 from this side and from that side as well. Plus we have this y-intercept here at -1, which shows right there. And then if you look at that first graph, it was doing the reverse of it. It's the +1 for the y-intercept. I think if we got rid of that sign, that would probably be this graph. And then this is one with the negative in front. So hopefully that helps.